Hello and welcome to our second lecture. As we said about the numerical system in previous lecture, and you can see the link of that lecture in the description section under the video. You may see that at first, and right now come to the lecture. Today's lecture is the logic gates. Okay, we have a lot of gates. We have 8 type of gates in DLD or digital logic system. We will use these all of gates in a PLC programming system and as well as in industrial controlling system for the factories as well. And we'll make the practical lectures on that section as well. And after these lectures, after 5-6 lectures, okay. So the first gate that we'll study is the buffer. Okay, buffer is like this. Okay, it has one input and one output. Buffer is used in some ways, sort of like the normally open gates as well. When we have the 0 input, the output is also 0. When the input is 1, the output is also 1. So this gate is used in some sections, for example, when we want to start one machine with another one as well, or for example, when we want to start the one load with another load as well. So we can use this gate. So we can make a diagram for that. We have one input and one output. As the input is 1, so 1 digit, so it can be 0 or 1. If the input is 0, so the output will be also 0. If the input is 1, the output will be also 1. So come to the second gate. Second gate is inverter or NOT gate. Okay, NOT gate. It is like this. Okay, there's a NOT at the end. So it has also one input and one output. In this gate, we can say as well the normal closed gate as well for it. It's used for a motor or for the system when we want to, for example, when we want to have the reverse or forward system. When forward is on, so reverse should be off. Or if the reverse is on, so the forward should be off to deny the shortage of the current and shortage in the system as well. So when we have the input 0, okay, the output is 1. When the input is 1, the output is 0. We can make the diagram for it as well. Input, 1 output. So the input is 1 digit, so it can be 0 or 1. If the input is 0, the output should be 1. If the input is 1, the output will be 0. So it's used in some where we want to off the system because of the starting of the another system. The third gate is OR gate. OR gate is like this. For example, it has 2 input, A and B, and 1 output. And here, if the 1 input is on, so the output will be on. This is the formula for this. For example, if A is on, B is off, so it will be on. Or we can say we can start the motor from 2 places. If we push the first one, it should be on. Or if we push the second one as well, it should be on. Okay, we can make a diagram for it as well. A, B, and output. So it's 2 digit. It can be 0, 0, A0, B1, A1, B0, A1, B1. If A is off, B is off, so the system will be off in output as well. If A is off and B is on, so we need 1 digit to be on, okay? It will be on. If A is on and B is off, the system should be on in output. And if the both of A and B are on, so the output will be on. Okay, the fourth gate is AND gate. It's like this. It's two input, one output. As we know, the AND gate is like this. If one of the input is 0 or off, the output should be off. So for example, if A, B, and output is 2 0 0 0 0 1 1 0 and 1 1. If A is off and B is off, the system should be off because it's AND gate. The both of the loads should be on for the for having the output on. Okay, if A is off, B is on, output is off. If A is on, B is off, so also output is off. So if A is on and B is also on, so it will be on in output as well. So it's used for the very dangerous places. For example, when we have a catcher and we use two buttons for that to push the both of the button at the same time to operate that brush or that cutter to be in safe zone. When we, for example, when we push the one button and the other hand is inside the cutter, so it's dangerous to be operated. So we should use the both of the button to operate that cutter. So thank you very much. If you have any question, you may say in the comment section, and we'll meet in another lecture.